guys, welcome to Unit 7. So in this unit we're going to be covering primarily exponential functions. This is the third and final kind of function that we're going to cover in the course. We've already covered linear, we've covered quadratic, and now we're going to talk about exponentials in detail. So we're going to start by kind of looking at a new kind of sequence. So if you remember way back in lesson 2.5, we talked about arithmetic sequences, and those were just patterns of numbers where you were adding something or subtracting something to move from one term to the next. In sequence notation, remember that a sub n represented the nth term, and that becomes sort of your output value. N serves as your input value. It's kind of like your x. So n stands for the term number, which is also known as the index. We usually just refer to it as the term number, though. So if you see something like a sub 4 equals 16, that means that the fourth term in your sequence has a value of 16. So like I said, arithmetic sequences, we were adding common differences to get from one term to the next. And we told you then that there was another kind of sequence that you might come in contact with, and then those are geometric sequences. Rather than adding a common difference to each term, we're going to be multiplying to move from one value to the next. The value that we multiply is called the common ratio, and instead of using a d like we did for common difference, we're going to use an r. So that's our common ratio. So when I'm looking at these two to determine whether the sequence is arithmetic, geometric, or neither, then all I need to do is look and see what's happening to move from this first term, this a sub 1, to the second term. Well, I could say I'm adding 9, but 12 plus 9 is not 48. So the next thing I'm going to look at is, okay, I'm multiplying by 4. Well, 12 times 4 is also 48, and 48 times 4, if you check in your calculator, is 192. So that means that this is geometric. Okay, so I know it's geometric. If I were to ask you about the domain and range, one of the things that we try to stress that makes arithmetic and geometric sequences different from normal equations is that your domain is restricted. You don't have a domain of all real numbers like a normal exponential function. Instead, the only numbers you're going to plug in are your 1 for your first term, your 2 for your second term, your 3 for your third term, and so on. Another way you could say that is it is just your natural numbers. That is always going to be the domain of an arithmetic sequence. Your range is just your sequence because your outputs are your range, just like they are in a normal function. Well, here, my range is not going to be all real numbers. My range is going to be this 3 that I get when I plug in 1. It's going to be this 12 that I get when I plug in 2, and 48, and so on. All right, so let's do another example, one that's getting smaller. So if this were arithmetic, then I'm subtracting 4, except 4 minus 4 is not 2. So I've got to see if I can multiply or divide. To get from 8 to 4, I'm dividing by 2. To get from 4 to 2, I'm dividing by 2. And that's going to continue to flow. 2 divided by 2 is 1. 1 divided by 2 is 1/2. The problem is we can't write this in terms of division. We have to write it as multiplication. So if I were going to talk about the r in this case, I would say I have an r of 1/2. Because multiplying by 1/2 is the same as dividing by 2. So when you figure out what you are dividing by, you can just set it as a fraction with a denominator of 1. Okay, so because I found a common ratio, I can say that this is geometric. My domain, as with all sequences, is going to be those natural numbers, 1, 2, 3, 4, and so on. And my range is going to be the outputs, so 8, 4, 2, 1, 1/2, and so on. All right, and that's it for this first video. Hopefully it wasn't too terrible. You guys go ahead and try a couple. Let me show you one quick thing before I let you go. All right, so I grabbed my calculator because I want to show you if you are having trouble telling what's happening to move from one term to the next, what that common ratio is. Then what you can do is say, take the second value, so in this case like 4, and say 4 divided by 8. And that gets me that 1/2. And then I can check the next one and say 2 divided by 4. And that also gets me 1/2. So I'm getting a common ratio. In example 1, 12 divided by 3 obviously gets me 4. If I said 48 divided by 12, I would get that 4. So if you take kind of your second term and divide it by your first term, that'll give you your common ratio. Most of the time you can find it just by looking, but I just wanted to show you that just in case you had one that was a little more difficult to see. All right, you guys try it and be sure to check your answers, and I'll see you in the second video. Bye!